Right. Thanks again, kids. Thank you. Thank you. Up next in our math cast, in our sequences and series chapter, today's topic, Part C, arithmetic sequences. So as we've seen already, we're getting used to the idea of a sequence, and we've spent a little bit of time writing what we call the general term. This is the example we had previously. We know that we were able to figure out we're adding 2 every time as we progress, and we were able to figure out that initial term was at position 0. So over here at 0, we knew that was a 1, and we reminded ourselves it was really a version of y equals mx plus b. Ended up being y equals 2x because 2 was the jump every time, and plus 1, that was the initial value. We rewrote that in terms of sequences and series variables using u for the value of the term and using n for the position of the term. Well, there are different types of sequences. One of the main types is called an arithmetic sequence. And to recognize that, an arithmetic sequence, or in an arithmetic sequence, terms are generated using a constant common difference. So what that means is we are adding or we are subtracting as we go from step to step through the sequence. For this addition or subtraction, we're going to use the variable d in our model. So take a look here at the example below. If we're given 4, then 7, then 10, I could say to you, tell me the next couple numbers. We start at 4, we go to 7, we add 3. We start at 7, we go to 10, we add 3. I could say find the 6th term. So that's 1, that's 2, that's 3, 4, 5, 6. I would add 3 again to 13, add 3 again, 16, add 3 again, 19. That's pretty straightforward. But of course, I'm not just going to say find the 6th term. I'm going to ask you to find a term that is very deep in the order. So you're going to have to use the general term or the equation to find it. So let's just take a look at this sequence, and we're going to try to look for some patterns here, and we're going to try to write the model for an arithmetic sequence. So we start at 4, again, then we have 7, and then we have 10, and then we have 13. And I know that term 1 is equal to 4, okay? Term 2, so that's term 1. Term 2 here, it's equal to 4 plus, I'm adding that 1, 3. 4 plus 3 is 7. Term 3, over here, I start at 4, and now I'm adding 2 jumps of 3. So I start at 4, I go once, twice, 2 jumps of 3 to get over to 10. Okay. Term 4, over here, again, I start at 4, and I'm adding 3 jumps of 3. So I start at 4, 1, 2, 3 jumps of 3. Okay, so we seem that you see there's a bit of a pattern here. If I look, I see every time I'm starting with my first term, term 4. So all these are based off of that term 4. 4, term 1. And I see I'm adding 3 to advance through my values. Adding 3 every time. And I see that the value of term 2 can be written in terms of term 1. And the value of term 3 is written in terms of term 2, and so on. Term 4 can be written in terms of term 3. Really term 4 is just, it's off by 1, term 4 and 3, because we've already have one term almost accounted for. So with this, keeping this in mind, we can write the general model. We're going to use U1 for the first term. We're going to use D for our common difference. We're going to use UN for the value of whatever term we're trying to find. And we recognize that we are just multiplying by n minus 1 every time. Okay? If this is n, we're short 1 over here. If this is, I'm looking for the fourth term, it's 3 multiplies. If it's the third term, it's 2 multiplies. The reason why it's off by 1 is that we already have one value sitting in there. We've already taken into account one of the values. They can all be put together and written in terms of the general model, where it's u1 plus n minus 1 times how many jumps, or d. So the general term of an arithmetic sequence, u1 is the initial term, d is the common difference, and n is the term number, and this is the equation. So let's go back here to our initial question we had that we just kind of worked out. Find the sixth term. We worked it out before. I believe it was 19 from a few slides ago. We're going to verify this with our formula. u1 is 4, so the first term here is 4. My d, my common difference, I'm adding 3 every time. And I'm being asked to find the sixth term, so n is 6. So I would have t subscript 6, that tells me I'm finding the sixth term. I start at my first term, and I'm adding to that 6 minus 1, 5 jumps. So I start at 4, and I make 5 jumps of adding 3. 1, 2, 3, 4, 5. And I'd add 3 every time. So that, of course, is start at 4. I'm adding 5 jumps of 3. That's 15. So 4 plus 15 is 19, as we knew it would become. So another question where we were not really going to figure it out by hand. Find the 53rd term, starting at 5, then 13, then 21, ... It works out to be, we're not quite sure. So we're going to use the formula on this one. The first term is 5. D, the common difference is 8. So 5 plus 8 is 13. 13 plus 8 is 21. 21 plus 8 would be 29, and so on and so on. And I'm being asked for the 53rd term. So n is 53. I plugged in my formula, t subscript 53, start at 5, and add. Basically, 53 minus 1 is 52 jumps of 8 every time. So 5 plus 4, 16. So the 53rd term is 421. Now, another little twist on this general term formula that comes in handy. It says, for an arithmetic sequence, the final term is given. How many terms are there? So in this sequence, we start at 3, we go to 5, then 7, then 9. It's pretty easy to see we're adding 2. And then we have a whole pile of jumps in here, and then we end up at 119. So we know un. We know the last term. The question is, what is n? How many terms are there? How many numbers do I have in here in my entire sequence? Well, still, we're going to use the term formula. And my u1, my first term was 3. I know my common difference was 2. And in this case, I'm going to substitute in for un, 119. So here's my 119, my 3, and my 2. I'm trying to find n. That's the question mark. Well, it's pretty easy here. I could just do distributive property, the rainbow rule. 2 times n is 2n. 2 times -1 is -2. I collect my like terms. I have 3 and a -2. That becomes 1. I subtract 1 from both sides. -1, -1. 119 minus 1 is 118. And I divide both sides by 2. And that leaves me with n equal to 59. So there would be 59 terms in this sequence. If I were to write it all out, I had the first term, second, and third, and then down in the 59th spot would be 119. Okay, there are a few examples in your textbook I'd like to use as guidance, and you'll see them. They're on page 42, some of the questions as well. Page 42, 1 to 3, 5AC, 6 and 7. That's it.